We'll discuss here the main properties of logarithms. They follow from the laws of the exponents. Property number one is a product rule that says that the logarithm of the product is the sum of the logarithms. It doesn't matter what the base is, as long as it is positive and different than 1, the property is going to hold. Now let's briefly justify that property. If x is equal logarithm to the base a of m and y is logarithm to the base a of n, then rewriting these equations in the exponential forms will give me a to the power x is equal m and a to the power y is equal n. If we multiply now m times n, we'll get a to the power x times a to the power y. And since multiplying exponents with the same base means that we keep the base and we add the exponent, the equation can be rewritten as m times n is equal a to x plus y. Now if we turn this exponential equation into logarithmic one, we'll have x plus y is equal logarithm to the base a of m times n. And this is exactly the property because x is logarithm to the base a of m and y is the logarithm to the base a of n. Let's look at an example where this property can be applied. We have logarithm to the base 5 of 10, and if we write 10 as 2 times 5, we can use the property and rewrite that logarithm as the logarithm to the base 5 of 2 plus logarithm to the base 5 of 5. And since logarithm to the base 5 of 5 is 1, we can write it as a logarithm to the base 5 of 2 plus 1. This property can also be written in the reverse order, starting with the sum of the logarithms and ending with the logarithm of the product. And in this way, we are saying that the sum of two logarithms with the same base is logarithm of the product of the inputs of logarithms on the left. So, for example, if I have ln of x plus 1 plus ln of x minus 1, I can write it as ln of x plus 1 times x minus 1. And since x plus 1 times x minus 1 is x squared minus 1, I can write it as a single logarithm ln of x squared minus 1. Quotient rule is the property that tells us how to take the logarithm of the quotient. If we want, we can write it as the difference of logarithms, logarithm of the numerator minus logarithm of the denominator. So if we have logarithm to the base 4 of 15 over 2, we can write it as a logarithm to the base 4 of 15 minus logarithm to the base 4 of 2. Since logarithm to the base 4 of 2 is 1/2, we can further compute this and write that this is logarithm to the base 4 of 15 minus 1/2. If we look at this property in the reverse order, the property will say that the difference of two logarithms can be written as the logarithm of the quotient. So if I have logarithm to the base 4 of 12 minus logarithm to the base of 3, I can write it as the logarithm to the base 4 of 12 over 3. And since 12 over 3 is 4, this results in the logarithm to the base 4 of 4. And this logarithm in turn is equal 1. Last rule is the power rule that tells us how we can deal with the logarithm of the exponent. As you can see, we have exponent m to the power r. The exponent or the power can be taken out of the logarithm entirely and made as a factor in the expression. So if I have log of 3 to the power x, the exponent x can go outside of the logarithm and I will have logarithm of 3 only. This logarithm has the base 10, that's why the base is not written. And in the reverse order, the property says that if I have the product of a number and the logarithm, then that number can go inside the logarithm as the exponent. So if I have 5 logarithms to the base 3 of x plus 1, that 5 can go inside as the exponent of x plus 1, and that product can be written as logarithm to the base 3 of x plus 1 to the power 5.